Today we're talking about the idea of a regression equation and modeling our tables of values with an equation. So we're going to talk about how to use our graphing calculators. You're going to need to have a graphing calculator out for this lesson. For Unit 1, we're going to work with just linear, quadratic, and cubic. It says quartic, but we're not going to do any of the quartic ones this particular section. So on your graphing calculators, this is all based off of the TI-84. Please note that the TI-84, if you don't have an updated system on your TI-84, first off, you can go to the TI website and use your connector cable and plug into your computer, and you can download the updated software on a TI-84. But if you have a TI-83 with the old system on it, or an outdated TI-84, these are not necessarily, the button sequence is the same, but the commands might not look the same. I'm going to create a separate video with how to use the outdated system on a TI-84 or an 83. But to begin with graphing calculators, to build a regression model, you're going to hit the Stat button on your calculator, and then go to Edit, and then you're going to get these nice little lists. Anytime you have a table of values, you're going to enter the X values into list 1, Y values into list 2. If you have data values in the lists, just arrow up to the L1 or the L2 up here, just arrow all the way up and hit clear. Don't hit delete. If you hit delete, you're going to actually delete the entire list. You don't want to do that. If you happen to accidentally delete your lists, you can come back into this Stat and Edit menu and go to number 5, and that Setup Editor will add those lists back in. But once you've got your lists entered, then in step 2, you're going to go back to that Stat menu, and then this time you're going to go to Calculate. And then there's a couple of linear regression options. So number 4 says linreg ax plus b, and number 8 says linreg a plus bx. It really doesn't matter which one you pick, but a lot of times they'll ask you to use number 8 and write the x term second, but just know it doesn't matter. Either one of them will give you the same linear equation. And then you can also choose cubic regression, which is number 6, or you can choose quadratic regression, which is number 5. If we do quartic regression, that would be number 7. Once you hit whichever regression you want, you're going to get this menu if you have the updated system. This is where it looks different if your system's not up to date. For X list, you're going to want to use list 1. That's the one we used over here. This was our X values. This was our Y values. For our Y list, we're going to use list 2. For right now, you're ignoring the frequency list. And then if you want to store your regression equation, which you probably will want to store your regression equation because we're going to use our regressions in order to make predictions later, you can store it as Y1. And in order to store that regression equation, to enter Y1, you can press alpha and then trace and select Y1. The other way you can do this, I'll write the steps out. You can go to VARS, and the VARS button is right here. So you can go to VARS, and then you can go to Function and Y1. So it's in that VARS button right there. That's another way to get to Y1. All right, so let's practice it. You're going to enter all of these values into list 1, enter these values into list 2, and then we're going to hit Calculate Linear Regression, L1, L2, store into Y1. And you can pause the video, but here's what your screen should spit out. If these values don't come out on your calculator, you're going to need to go to the Catalog button on your calculator. And the Catalog button is right here. It's above 0, so you're going to need to hit Second and Catalog. and then you're going to need to arrow all the way down until you find the word diagnostics on. And you need to make sure you turn your diagnostics on. Once those are on, then those R squared and R values will show up. But we can see we've got our equation, a plus bx. So my regression model would be y equals 3.545 plus 0.185x, because I know the b goes with the x. If I had done LinReg number 4, if I had done the ax plus b, then my a value would have been 0.185 and my b value would have been 3.545. So now you've got that nice little regression equation, and we said to store it as y1. And so now it says to use our model to predict when the baby is 10 weeks old. And so you can quickly find that by finding that y1 value on your home screen. So again, you can go into that vars function and y1, and then just put parentheses 10, and you're going to end up getting 5.395. So everybody practice putting that into your calculator. Last but not least, part C, it says the weight of the 6th baby is 5.3 kilograms, and they want you to use your model from part A. And then it says, what is the age in weeks of this baby? All right, so our equation was 3.545 plus 0.185x. And they're saying, when does that reach 5.3 kilograms? And so when we solve, you end up with 9.486 weeks. All right, so the question comes, how do I select which model I want to use? How do I know if it's linear, quadratic, or cubic? When we talk about linear models, we're talking about those constant rates of change. So it's going up or down by that same amount every single time. Approximately. These are real world situations, so they're not going to necessarily be perfect. For quadratic models, we're looking for roughly linear rates of change, or it's symmetric with a single max or a min value. So we're looking for the numbers to go up and down, and we're looking for kind of a vertex in the middle. And then typically, if the model involves something like area, so if you ever see something like units squared, then we're talking about a quadratic model. When we talk about cubic models, we're talking about things that are involving volume, so cylindrical volume, spherical volume, anything that uses something with units cubed, then we're going to be using a cubic model. So let's try a couple. In example 2, we're going to determine whether these are linear, quadratic, or cubic. So here it says, balloons are filled with water in preparation for an epic water balloon battle. I can already start guessing that I'm going to see some volume if I'm filling something. Each water bottle is roughly spherical. The radius of each water balloon is measured relative to the amount of water it holds. So we're talking about a volume here. So this one would be a cubic model. Letter B says Totino's pizzas are on sale at the local grocery store. The price of one pizza varies from $1.99 to $2.19 depending on the variety. The total number of pizzas are counted relative to the total price of the purchase. So as I purchase more pizzas, the price will be going up at the same rate every single time, approximately. And so this one is linear. Last but not least, a sprinkler is placed in a yard to water the grass. The sprinkler rotates in a circular pattern and waters all the grass between the sprinkler head and the furthest distance it reaches. The radius of the circular path is measured relative to the area, there's that magical word, watered by the sprinkler. So we're talking about area this time. This one happens to be a circular area, and so this one would be quadratic. All right, so this time, let's look at this table set of data. We need to decide, are we going to do this as a linear, a quadratic, or a cubic? I can see that my numbers are going up, and then they start to go back down. And so if they're all going up, somewhere in here, we're going to have a vertex. So it looks like we've got somewhat symmetric here. So if I look the 5 and the 2.8, 10.6 and the 10.2, if I'm kind of bouncing back and forth, these are fairly symmetric, and it looks like they went up and then back down. So I would say that this is a quadratic model. So go ahead and put these into your calculator, into list 1 and list 2, and then you're going to hit the regression equation. This time you're going to choose quad reg, and what I got here was negative 4.883 x squared plus 15.958x plus 4.996. Last but not least, we're going to talk about residuals. So when we use a model to predict values, we expect that our model is going to produce values that are reasonably close to what the actual values are, not always going to be exact. So the difference between an actual value and the value that was predicted is called a residual. So we call this symbol y hat. It looks like it's wearing a little hat. So y hat means our predicted value. So we're going to do actual value minus predicted value to find the residual. So here I've given you another table of values. This is the same one from the very beginning of our lesson, and so we ended up with the linear equation 3.545 plus 0.185x. So that was our linear approximation here. And so we're looking at the baby that is 5 weeks old. And so they're telling us at 5 weeks old, the weight was 4.4. I want to use my linear equation here to find my predicted value. So take this function and plug in 5 for x, and you get 4.47. So it's close to the actual value, but we're using this rounded value from our linear regression. So to find our residual, we're going to do the actual value minus the predicted value, and we can see that we were off by 0.07, negative 0.07. So our interpretation there would be then at time equals 5, at t equals 5, the model overestimated. So we were actually under what we were supposed to be. Over what we were supposed to be. So the model overestimated the actual value. All right, that's the end of this lesson. There's going to be some additional pieces to this lesson coming up.